Chapter 8, Objects and Classes, Part 2. Instantiating objects. Objects are created based on classes. You can think of an object as being like a variable of a primitive data type. However, objects are variables of abstract data types that the programmer makes themselves. We need the keyword new to construct objects. The keyword new does three things. The new operator does three things. Number one, it allocates enough memory for the object. Number two, it calls the constructor. And number three, it returns the address of that memory so that the object name or the object variable on the left-hand side of the equal sign stores the address of where that object is in memory. We've used the operator new before, as in scanner in equals new scanner system.in. Scanner is a class and in is an object of the scanner class. So if we want to create a couple of objects of the counter class, we can say counter concert counter equals new counter and counter boarding counter equals new counter. Each of these would have their own copy of the instance field's value. We can design a method named count that adds 1 to the instance variable, such as if we look at the code in blue, public void count value equals value plus 1. When we call that instance method, it will add 1 to the private instance field value. We also can create a get value method to access that value. It returns the contents of value. The public interface of the class is all of the public methods in the class. So when you design a class, you start by specifying the public interface of the new class. So assume we're creating a cash register class. We ask what tasks would that class perform? What methods do we need? What parameters will the methods need to receive in order to do their job? And what will the methods return? So if we're thinking about our cash register, we might want to add a price of an item. We might want to get the total amount owed. We might want to get a count of how many items are being purchased. And then we might want to be able to clear the cash register so that we can create a new sale. When we write the public interface, we might want to add some Java doc comments. Notice that Java doc comments start with a /*, and they help comment on the methods and the classes. So if we look at add item, we have /*, adds an item to this cash register. So that's a description of what the method does. And then we have @param price. So the @param is a Java doc keyword that says this is a parameter. And then we put the name of the parameter, in this case price, and then a description of what that parameter is for, followed by the close comment mark, the // Public void add item, double price, so we accept a double value that we're going to add to our current cash register. We've been writing, these both represent non-static methods or instance methods. We've also written static methods before. Static methods are methods that exist when no objects of the class exist. The most common example of this is public static void main string args. So the main method exists when no objects of the class exist. But the public interface of a class, those methods are instance methods. They only exist when an object of the class exists. There are two categories of instance methods: accessor methods and mutator methods. Accessor methods access instance fields, or we also call them get methods. They get the value in the instance field. They don't change it. They don't change anything, they just access it. And they normally return a value of some type. So that would be say we're getting total. Total is a double, so that method get total would return a double. Mutator methods are called set methods. They change or mutate the instance fields, the values in the object. They usually take a parameter that will change the instance variable, and they typically return void. So taking a look again, let's talk about the Java doc comments. It's important for us to comment our code. The Java doc utility generates a set of HTML files that follow a specific style. If you look at the help files from Oracle that you can find just by Googling any Java topic. You'll see that they're all formatted in the same way. They are created using the Java Doc utility. In this example, looking at this method summary, this was created using the Java Doc utility. And it creates that nice standard formatting that makes it really easy to document our code. Designing data representation. So an object stores data in instance variables. So remember that a class stores data and methods that act on that data, and it's called encapsulation. So when we're talking about the data, these are the variables that are declared inside a class. All methods inside the class have access to them. All methods can change or access them as the programmer sees fit. What data will our cash register methods need? They need the price of the item. If we're going to add a price of an item, we need to access the total, as well as the count, because if we're adding the price of an item, we want to make sure that we increase count by 1 because we're adding an item. We want to get the total of the amount owed, we want to get the count of the items purchased, and then we want to be able to clear the total and count.